You're deploying a new app to Heroku. Their docs say, add a CNAME record. You do it for www.yourdomain.com, works perfectly. Then you try the same for the root domain, yourdomain.com, and hit an error. CNAME records cannot be created for the root domain. This isn't Heroku's fault. It isn't a bug in your DNS provider. It's a rule baked into the DNS specification itself. And it's been there since 1987. In this video, I'll explain exactly why this rule exists, show you how CNAMEs work under the hood, and walk through Name.com's name record, the clean solution to this problem. I'll also cover the 3 most common CNAME pitfalls that break production setups. Before we get into the root domain problem, let's understand what a CNAME actually does, because it's not what most people think. A CNAME doesn't answer a DNS query. It redirects it. It tells the resolver, don't look for an IP here. Go ask about this other host name instead. Let's see a real-world example using the dig command. I'll query www.microsoft.com. Look at the answer section. www.microsoft.com points to a CNAME. That CNAME points to another, which points to another. And finally, we get an A record with an actual IP address. Every one of these hops is a separate DNS lookup. Each adds latency. For users on mobile or far from your name servers, a chain of 3 or 4 CNAMEs can add 150 to 300 milliseconds before the connection even starts. So why use CNAMEs at all? Because cloud platforms change IP addresses without warning. When Heroku moves your app to a new server, your CNAME to coolapp.herokuapp.com keeps working automatically. An A record with the old IP would break until you manually updated it. CNAMEs give you flexibility at the cost of lookup speed. Now, here's the rule that causes the root domain problem. RFC 1034, the original DNS specification from 1987, states that if a DNS name has a CNAME record, it must not have any other record types associated with it. Also, RFC 1912, section 2.4, makes it explicit. A CNAME record is not allowed to coexist with any other data. The reason is architectural. A CNAME says, this name is an alias, go look somewhere else. If other records existed alongside it, the resolver would have contradictory instructions. The protocol forbids the conflict by forbidding the coexistence. So why does this kill you at the root domain specifically? Your root domain, example.com, is required by DNS to always have 2 records, an SOA record, which defines who manages the zone, and NS records, which point to your name servers. Without these, your domain doesn't exist on the internet. So if you try to add a CNAME at example.com, you're asking DNS to do 2 contradictory things at once. Ignore this name and look elsewhere. That's the CNAME. And use these name servers. That's the NS records. The protocol refuses. There's a third problem too, email. Your root domain needs MX records for user at example.com to receive mail. A CNAME would invalidate those MX records entirely. The standard workarounds all have real problems. You can use an A record with the platform's IP, but that breaks silently when they change infrastructure. You can redirect the route to www, but that's an extra hop on every visit and you lose the clean URL. Or you give up on the root domain entirely. None of these are good. This is exactly the problem that Name.com's A name record is designed to solve. An A name record isn't part of the DNS spec. It's a feature Name.com's name servers provide to work around the zone apex limitation. Here's how it works. You create an A name record pointing to a target host name, like your app.platform.com. Name.com's name servers periodically resolve that host name themselves to get its current IP. When a DNS query comes in for your root domain, Name.com returns that resolved IP as a standard A record. To the rest of the internet, your domain looks like it has a normal A record, but it's automatically updated in the background whenever the target host name changes IPs. You get A record speed with CNAME flexibility. And you don't violate any RFC rules. because your SOA and NS records are untouched. Let me show you how to set this up in Name.com. I'll navigate to my domain's DNS settings and add a new record. I'll set the type to a name. For the host, I'll use the @ symbol. That represents the root domain. In the answer field, I'll enter the target host name from my platform. For TTL, I'll use 300 seconds, 5 minutes, which gives Name.com's name servers enough time to detect IP changes and propagate updates quickly. I'll save the record. Within a few minutes, Name.com's name servers will resolve the target host name and begin serving the correct A record to resolvers worldwide. Now let's look at the 3 CNAME pitfalls that most commonly break production setups. The first is wildcard CNAMEs in email. You might think this configuration causes a conflict. A wildcard CNAME for star.example.com pointing to your platform, plus an MX record on mail.example.com. Actually, that's valid. Wildcards only apply when no explicit record exists for the queried name. Because mail.example.com has its own MX record, the wildcard doesn't apply to it. But the next configuration is invalid. A CNAME on mail.example.com and an MX record on mail.example.com. Same name, 2 record types. The RFC forbids it. Your DNS provider will reject the second record, or worse, serve unpredictable results. The second pitfall is TXT record conflicts. You can't add a TXT record to a name that already has a CNAME. The exclusivity rule covers all record types, not just MX. This comes up constantly with domain verification. A service asks you to prove ownership by adding a TXT record to app.example.com, but that subdomain is already aliased via CNAME to your platform. The TXT record will be rejected. The workarounds? Verify at the root domain instead, where you can use TXT records alongside your A name, or use a verification-specific subdomain that the service provides, like _verification.example.com, which won't conflict with your existing CNAME records. The third pitfall is CNAME loops. Easy to create accidentally, and they cause complete DNS chaos. If a.example.com is a CNAME pointing to b.example.com, and b.example.com is a CNAME pointing back to a.example.com, the resolver enters an infinite loop. Most resolvers detect this after a few hops and return an error. The hostname becomes completely unreachable. This is obvious in a 2-record example, but it happens in real infrastructure when subdomains chain across zones you don't fully control. Before deploying CNAME changes, always trace the full resolution chain manually. The dig command with the +trace flag is useful for verifying this. To wrap up, here's the decision matrix for choosing the right record type. Subdomain to an IP, use an A record. Subdomain to a host name, use a CNAME. Root domain to an IP, use an A record. Root domain to a host name, use Name.com's A name. All of the pitfalls we covered trace back to the same RFC 1034 rule. A CNAME must be the only record for that name. Everything else follows from that single constraint. The full written guide with RFC references and Name.com's API docs for managing DNS programmatically is linked in the description. Thanks for watching.